Welcome to HP Tuner's GM Gen 5 training part 16. In this training module, we're going to be exploring the dynamic airflow parameter within our engine control module. So this is going to be looking at both mass airflow and speed density. We're going to learn how it all works and then learning how this is going to influence what's going on in our airflow modeling. We're going to have a lot to talk about. Let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at understanding our dynamic airflow parameter in our GM Gen 5 applications. The dynamic airflow is an essential channel that has to be calculated right because fuel, spark timing, and torque calculations hinge upon that reading. Now we have two different airflow modes that are going to be operating at the same time in our GM Gen 5s. We have both mass airflow and we have speed density. We need to understand what those represent in general terms. We'll have separate tutorials coming up here in our training course looking at all of the different aspects of calibration and those specific airflow modes, but we need to understand how those modes and the basics of those modes work within this dynamic airflow because it's going to be a composite blend between mass airflow and speed density. So we're just going to break down how this all works. We're also going to be taking a look at some VCM scanner log data. I have some sample data logs that you can open up and follow along with for this tutorial. We can just determine what specific airflow mode we're in and how the dynamic airflow is going to be reading. So let's jump in here and let's take a look at how this is all going to break down. So I have a 2018 Yukon Denali Gen 5 file that I have open here. You can open up any Gen 5 file to follow along for this tutorial. If we go up here into our engine tab, and then we go into our general here, and we work our way across into airflow, we find that we have these three separate tabs here: general, dynamic, and speed density. These fit together to form the airflow model. Specifically in our general tab, we're talking about our airflow versus frequency mass airflow calibration table. Now, let's talk about the mass airflow and the role it plays, just in basic general terms, and then we'll talk about our speed density here and the role it plays in the airflow model, and then we'll learn how the dynamic fits in here and actually works between both of these. So, when we're talking about a mass airflow sensor is fitted to the intake track of our engine. It's going to be fitted into the actual intake itself. We have airflow that's going to be coming into our engine. It's going to go across the mass airflow sensor. The mass airflow sensor is calibrated to send a frequency signal back to the engine control module in order to report back what the amount of airflow is going to be. So it's a proportional signal. Airflow comes over the sensor. It sends out a frequency hertz-based signal. And we can find it looks it up here in this particular table. It's a pretty straightforward process. So it's going to output a frequency. We look at the frequency it's outputting from the sensor, and then we look down here in the table, and it's a one-to-one lookup. This will be what the actual airflow is going to be in grams per second, or whatever unit scale you're going to be working in. So pretty straightforward there. Now the mass airflow sensor is really only valid in terms of its reading in steady state conditions. We can't have a situation where we're having rapid throttle changes and we're having bursts of airflow entering our engine. If we have a transient condition, let's say we're going from off throttle and we're then slam the throttle all the way open, we have a huge burst of airflow, and the mass airflow in that situation isn't going to be super accurate in terms of the air mass. Now we're going to find that in steady state conditions, the mass airflow sensors are incredibly accurate. So we'll find at idle, where the throttle is fixed and relatively steady, we have steady state airflow. The mass airflow sensor has a great signal. Cruising conditions. So if we're on the highway, we're cruising, let's say 65, 70 miles per hour, we have steady state airflow. The mass airflow is going to be a great registration of airflow. And at full throttle, even though we have airflow coming into the engine relatively quickly as the engine speed picks up, it's still in a relatively steady state condition. And we'll find in any of the steady state conditions, the mass airflow sensor is the preferred way for the engine control module to register and reference what the airflow coming into the engine is going to be. Now we're going to find that the fuel, spark, and torque calculations all hinge upon airflow. So we need to make sure that the airflow or air mass registration is accurate, or else we'll have problems with the drivability of our car. The drive-by-wire throttle control can be screwy because it's torque-based. Torque is a function of airflow. In fact, it's calculated based on the airflow. So the mass airflow sensor needs to be calibrated right, which we're going to take a look at how to do that. But just understanding that the mass airflow sensor is the engine control module's preferred method of detecting the airflow or air mass coming into the engine under steady state conditions. Now, we're going to find ourselves in a situation where we have transient conditions. Let's talk about that, and let's talk about speed density. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.